Good afternoon, everybody. So now you see to Singapore for the second time. Last week it was with Stefan Müller, Arizona, and we always sit in the same place here for the next few weeks, still because it's the only place from where we can communicate well. It's not as sophisticated as in your place, but I hope you can understand us. Today it's information components of future architecture, and I want to give you a brief outline. I want to start at the very beginning with a few questions and answers that you treated in the last two lectures. Then we look at examples from your exercises, and I would like you to speak briefly about your individual exercises that we will look at. Then we revisit these definitions of data, information and knowledge, then explain what information components are, how we see future architecture connected to it, and a brief summary. Revisiting the lecture 2 and 3 and your student questions, it is great because I could then watch everything that Daniel Aliaga and Stefan Müller had spoken about, and you probably could see that too if you had missed the lecture itself. So with Daniel Aliaga, you heard a lot about procedural models and inverse procedural models, about creating trees, building cities, weather, and it was almost like a mirror of what we as architects do, which other people who not necessarily have studied architecture see as a result, and they're trying to recreate the result and represent the result. So it was, for me, watching this lecture very interesting, almost, as I said, a mirror. And the mirror shows a lot of truth, but also it shows many things that you can not see, and it also hides many things that you see if you look somebody directly in the face, or in this case, in the face of architecture. And then from last week, the questions that you posed, I thought were very insightful. That was very good. You had the answers from Stefan Müller, Arizona, but I just want to give you one or two more answers to it. So somebody asked about how does the semantic web influence architecture? Does it? And my opinion is very clear. It will influence the future architecture, and we can see a few of the things coming. And if you want to know exactly what it is, look at the BIM, this Building Information Models, that you have treated probably in other courses. So this is one aspect of it. And then there was the question, will architects be the decision makers in the future? I think they always have been, but I hope that they will be better informed decision makers. So you, in these courses that are going beyond the core of architecture, I think will be able to make really better informed decisions. There was a question on, will architects be influenced by tools, or will they influence the tools? This is a very old question. It has never been answered, and I think both, of course, will happen. So one way and the other way. And this program, City Engine, that some of you are using in the other course by Jan Halaj, is a very good example how it influences each other both ways. And then finally, is programming one of the basic skills of future architects? Yes, of course it is. That's why we here at the chair offer these programming courses. But it is obviously not for all. So some people cannot do it. But if you do have the chance, do take it, and you will have an advantage out of this. By the way, can you just quickly give a show of hands if you do understand me correctly, or is there a big echo? Is it okay? As you hear me? Yeah? Okay, good. All right, so as I said, that was very interesting to listen to these lectures, and also to you asking these questions. I think this is going very well. Let's look into your exercises. Thank you for sending in the exercises, and I want to go through them quickly with you. And if you are there, maybe you, Severin Neukomm, can say a few words to it. Remember, the point was sustainable information architecture or sustainable information architecture. So you quickly say, if you can, what you see this example for, and where the sustainability aspect is in this example, except for this one being green, but this is only one of the many colors this display can show. Is Severin Neukomm there?
Yes, I'm here.
Okay, say a few words, please.
So I took an internship at that company who built this thing. So this is why I knew about it at the first place, and yeah, the thing that interests me about it is that you can actually interact with it, and it's not only programmed so that it displays a certain thing, but you can actually tell it what to do. And maybe that could be an interesting thing in the future, that you not only tell the computer one time what to do and it repeats it all the time, but you can actually influence it.
All right. Great. So that was actually a very good project and a lot of discussion in front of it before it happened. And being in such a public space and displaying information within a big architectural space and making an architectural element to display certain information certainly qualifies it for that. Thank you. And then Esen Marco, are you there?
Thank you. Thank you.
Ah, okay. Can you say a few words to that, the Bahrain World Trade Center?
Well, I saw this example on a documentary, and it's interesting because these panels there, they generate the energy that the building consumes. And there's this whole aerodynamics. The whole aerodynamics, for example, this is most probably calculated through computers and everything.
Okay, that's great. And by the end of the course, hopefully you should be able to figure out if what they are claiming there is true or not. So that will be the next step then. But certainly it's displaying the attitude or the wish that this is behind this building very clearly. Thank you. And Harry's P+, this is a very elaborate drawing. It's a bit difficult to read, but maybe you can explain what it is meant.
First, I apologize for the bad quality of the picture, but the little words are not that important. I think I just wanted you to see this kind of tree and of information, and just briefly explain it. I had some colleagues from MIT, and then they also strongly work with information architecture, and they argue if you want to create sustainable cities, you have to treat every aspect of the city, so every space, not only the building architecture and not only the landscape. So here, that's why I tried here to a bit to play with this, with words and with the word environment, the landscape, city, and information. So that's why the text is a bit longer, because I couldn't explain it in a shorter text. And this tree represents the amount of information in the environment, in the city, we should be able to read before we implement any solutions.
Right. Great. Thank you.
You're welcome.
And here a historic example from Hans Christian Leiderscher. Are you there as well?
Yeah, hello. I found especially interesting this example because somehow I think there's a loop between information architecture and information architecture. I want to try to explain it. It's like in order to build this pyramid, you need a priori a certain astronomical knowledge, and somehow it's being reflected again in times of equinox on the facade, on the stairs with the light, and I found especially interesting this aspect, this looping scenario.
Right, that's great, and it certainly is sustainable because being around for such a long time is a big sign of sustainability, no matter how you turn it.
Right.
Yes, so this is a good example for both of these aspects, information architecture and information architecture. That brings us right to the Technical Library in Prague by Katarina Novakova. Are you there? At the Czech Technical University?
Yes, I'm
No?
here.
Yes, you are.
You're on?
Okay.
I think this is a nice example of very low-tech combination of information and architecture. The Czech Technical University should be an information collection. The building should present the information as itself. So if you walk through the building, you gain the information about the building via eyes, sometimes via ears. You can read information on the walls. You can see it in graphically on the floors. So it's everywhere, and even in the information system of the building, new icons were constructed that you see on the right that are new developed or new design, especially for this building. So
Right.
it goes from the technical information to the artistic design information within the building. That's it.
Okay, that's great. I think libraries offer themselves really for this type of interplay between information and architecture. Obviously, they're made for storing information, and therefore this is a very good example. We have one more coming also from architecture and libraries. Here's the second one by you.
Yeah, I just send it anyway because I found this lately very interesting, that you can attach information on architecture. You can see the red unicorn, or is it unicorn, hippo over there. So if the
Yes.
device detects a sign on somewhere in the space in the real world, you can then see through the device some pictures that are like drawn and especially placed on the architecture.
Right.
It was called the virtual vandalism, but you can attach even 3D objects somewhere into the space. So this is interesting for me.
That will be more incredible in the future. Yes, these are
Yeah.
programs that are popping up now everywhere. As it looks like, it might even be Singapore. This Merlin that I see at the top. That looks like it. Yes, which is an artificial creation in itself, because it doesn't exist. Of course, it was the tourism board of Singapore who invented this creature. So this is a very fitting combination of virtual vandalism put together. Thank you. And now we're going back extremely to simplicity, to Yuji Mukayama. Are you there? Yes?
Maybe this is one of the most primitive example of information architecture, because this stone is showing information about something. Don't go over this stone, or don't go inside this way. And this is used for tradition of Japanese tea ceremony and Japanese traditional gardens. And we don't need any specific or sophisticated instruments for showing such information, and I think it's very interesting for us. And most interesting for this stone is it's connected deeply in one specific culture or specific context of tradition. I think that's all.
Yes. No, I can understand this quite well, because I wish we would have had these signs when we were in Kyoto 2 weeks ago in this big STS forum conference, when we were in this beautiful temple, and there were too many people, and this kind of signage would have been very good for all these people trampling through the temple. So I think that goes along with a certain type of tranquility and also density which is related to that, which you cannot increase too highly. But it's a very nice and simple example. Thank you. And then Katrin Zürcher, completely different example again, from Chile versus Plattenbauten. A few words to that. Are you there, Katrin Zürcher?
just a second.
I was just interested in how the law could affect the form of buildings and which one is more sustainable. Just on the one hand, the Plattenbauten, for example, in Berlin, today there aren't really beliebt.
Yes. And what do you think is the aspect of sustainability in these two examples?
Yeah, I just thought in Chile, or it's not in Chile, but there's another project in Brazil, and there they could build on their own. So I can't say it in English.
Say it in German, it's okay.
Es geht einfach darum, der Staat hat eine gewisse Struktur zur Verfügung gestellt, und zwar einfach die Hälfte des Hauses. Und die andere Hälfte des Hauses konnten eigentlich die Bewohner oder eben die von den Slums selber bilden, also in den Favelas. Und dadurch entsteht eine ganz eigene Dynamik. Und mit dieser Dynamik, indem man eben das eigene machen kann, entsteht etwas, wo man sich darin selber mehr wohlfühlt und einen größeren Bezug dazu hat. Nun ist eigentlich die Frage, ob das vielleicht insgesamt nachhaltiger werden könnte, als etwas, das ganz von irgendwelchen Architekten geplant wurde. Es geht mir eigentlich um den Aspekt, dass eigentlich was nachhaltiger werden könnte in Zukunft.
Okay, I see. So this is a very fine interpretation of this sustainability issue. And as a matter of fact, it's true what you say, because some of the favelas, in their growth over time and in their improvement over time, have in fact outlived many of these modern buildings that are on the process of being torn down, or only lived for 30 or 40 years and then were destroyed again. So now I see. Okay, thank you for the explanation. Because we have another example from East Germany a bit later. But first, Sebastian Ritter, are you there? No? Not there? Okay. So maybe he will be found by this piece of information that he left with us. But here it's obvious it's the code that makes a certain people from other cultures or times, maybe old people, they will not understand that this is a piece of that this is trying to tell us something. They might think it's just a piece of art or something, but there's really a lot of information encoded in this image, and that can be used, of course, in both ways, for information and for architecture metaphors. Then Maria Cecilia Chiappini.
Yes.
You are there. Are you in that studio? Working
Yes, I am.
in that studio, or?
Yeah. Well, the two images I took were, one is it's the same building. Basically, one is a real picture of the inside where we're working. And I was interested in this building because it's an industrial building. And as you can see, there's a big machine on the ceiling.
Yes.
Can you recognize it? So for
Sure,
me,
yes.
it's like a 3D arm. And it was thought and planned to be able to move information around the nave. And right now it's an architecture studio, so it changed the meaning, but still moving information around. And the other image is taken from Google Earth, and I found it great as an example of information architecture, because you wouldn't tell it's a picture or for the real building or if it's a reconstruction. I found these streets completely reconstructed by several images and information, very challenging for our perception, because they put you in a realistic situation, but it's just images and data. So that's why I chose it.
Right. So maybe also, I don't know if you did that before or after you heard Daniel Aliaga's lecture, the second class or the second lecture altogether, because there, of course, you could learn how this has been done and how he and his research group are doing this kind of mixing of reality and reconstruction and reverse procedural modeling of buildings. But the interior one, the first one, is certainly a real image taken from that real space. Thank you. And here's the second library example. Bibliothek der Hochschule für nachhaltige Entwicklung Eberswalde von Ramona Hablüssel. Are you there? That's a classic, huh?
Also ich habe dieses Gebäude gewählt, weil ich finde, es zeigt sehr gut, wie die Sprache, die Bildsprache nach außen getragen wird, also an die Oberfläche vom Gebäude. Und es ist ja auch eine Bibliothek, die Informationen beherbergt. Und ich finde es einfach ein spannendes Beispiel dafür.
So, would you say what you see there on the outside is information, or is it data, or what is it for you? Just look at the outside. For people who have no understanding what is inside the building.
Also außen auf der Fassade, das sind Fotos, die aufgedruckt sind mit einem Siebdruckverfahren.
Yeah. But does it sagt Ihnen das schon für sich etwas, oder sagt es Ihnen erst etwas, wenn Sie wissen, dass eine Bibliothek drin ist?
Nein, es sagt schon von sich aus etwas. Also es zeigt verschiedene Situationen auf den Bildern. Und das drin ist eigentlich etwas anderes. Es sind zwei gegensätzliche Dinge.
Right. Okay, und was ist sustainable? What is sustainable in this? What do you think?
Ja, ich finde, also die Nachhaltigkeit am Gebäude, ich finde, das ist eine Technik für die Zukunft. Also das, ja.
Okay. Good. And here we are in the Stalin-Allee, Donati Lorenza. Your interpretation of that?
She's not here, but I may say a few words. She chosen this picture because Stalin-Allee is a kind of information. It should represent Stalin or Karl Marx, and it's architecture to inform people about his totality, and it's sustainable because we can see it also today.
Okay. Yes, and it is using very simple rules actually to create it, and so far it's interesting from a research standpoint. You could recreate this Stalin-Allee and many others of this time easily with the, for example, the City Engine program that I was mentioning that Jan Halac is teaching. Okay, now this is a completely different form from Jong Young Jin. Are you there? The kiosk? Not here? No. Not here. Okay, good. So this is example from Seoul, and people check the quality of air and then can decide if they want to move. So it's like a huge information display, giving you indication how you should behave. Actually, I'm going to Korea, to Seoul tomorrow, and I have been there a little while ago, so I'm going to look for it if I find it. Then here, Mazda City from Daniel Schneider. What is your take on that? Are you in?
Yes, I am.
Yeah.
Yes, I took this one because it's clearly the ambition of Forster and partner to build a sustainable city, and it's really they working with information and with the new tools of dealing with the information, with how they work with wind and all the invisible factors like heat and everything to and they put this all together to to build a sustainable city. And I think it wouldn't be possible with the traditional form of planning and of building. It's like whole city with all the factors, all the information, with the aim to be sustainable. Yes.
Yes. Okay. I think this is also a very good example. And this is an example that's projected long into the future. And we will see, actually we do see already, how this clashes with reality. And later in the course you will see the parts of this master city that we simulated in terms of energy use and shadows and so on. And also some examples how it is really happening today. That you have to consider the human factor as well. And these very lightweight structures by Tobias Krieg, or by Hans Isler, but Tobias Krieg wrote about it. The Isler-Schalen, the famous ones.
Yes, Isler
Only a
shelves.
few left.
Yes, famous Swiss engineer. Built these shelves following the chain line, and it's information architecture because he can just change the information to produce architecture, and it's like generic tool for building these shelves, and it's sustainable in meaning of green sustainability by reducing materials and finding the most perfect structure.
That's right. I think that's quite a good example. If you look how primitive compared to that, some of the buildings that surround it are looking today, you can see exactly this point. And then the weather producers, Daniela Gempali.
Also ich wählte dieses Bild, weil man prognostiziert, was in Zukunft, also in den nächsten paar Tagen das Wetter ergeben wird, und macht daraus verschiedene Diagramme. Und gleichzeitig sieht man dann bei der in der Vorhersage, wie das Wetter ist, also was zum Beispiel bedeutet, wenn es so und so viel km/h Wind hat und so. Ja, also damit man genau diese Grafiken im gleichen Moment auch gerade besser versteht.
Exactly. So that's very very clear, and it also shows a few things that we want to talk about later today. And this course we do everything reverse, but this is quite good because then you have always examples to look at. If you see, for example, this gentleman standing there at the top left, looking at this red buttons, and it says Luftdruck 1002.9. This is a typical example. This is just data. This is, if you don't understand the context, that means nothing. But if you put it together with the context that you're in, you're talking about weather and so on, suddenly that becomes information, very important information for you. So that's a nice example. Thank you. Then Katharina Ehrenklau from Tokyo, the capsule hotels.
I was interested in this kind of rules or information which is sometimes written, sometimes unwritten, like the Neufert, where you have the rules about space. And to make this kind of transformation into architecture then later, and then you get this kind of architecture at its limit, and also how big can space be for people, and how much high-tech do you need in this kind of capsules, and this kind of architecture at its limit. And also sustainability, because cities are getting bigger and are growing, and you have to think about the space, or how you deal with the space, and what do you need with which kind of functions.
Also how to deal with density and this very special signature that they developed for that. Thank you. And we're coming close to the end. We have to speed up a little bit. The XCOM Couch by Jean-Marc Stadelmann.
The XCOM Couch is an art project where they built different couches at different places, and these couches interact with each other. So if one people sits on a couch in one place, other people at other places can see this by a visual sign, by blinking or by the slide. So they bring digital information into the physical world, and this can change the way we act or interact with the built world. I think this is pretty interesting.
And it is information architecture on the micro level, on the small scale of even furniture. So that's interesting, and this is totally the other scale now, the Eiffel Tower by Agda Koray. What's your reasoning for that?
My research was I was looking for a building that changed the information architecture over the years many times, and it was the Eiffel Tower. And another examples are the Great Wall in China or the pyramids in Egypt.
Okay, and it certainly is sustainable, and it can be used for many things today, and is used for many things, and has been used for many different ways in the path of its life, which is also a sign of sustainability. All right. And then the Enzo Valerio, the CERN, the particle accelerator.
Well, I think that laboratories are really an interesting place for information architecture, since it's the place where, well, information architecture, you'll find that a building is specially built for a certain research, or in this case even one experiment. So you got architecture that's really determined by the needs for this research or this experiment. So, and on the other hand, they actually use architectural elements like 3D buildings, as you see in the and networks to make the information that this experiment or the data that this experiment produces more clear and more easy to understand for the researchers, and they will actually use this to build new buildings for new experiments. And so the chain of information architecture and information architecture will continue to be input and output for itself.
Right. And now with the new findings they had there, that will even accelerate, probably. James Yeo? Here today? No? No. Not here today. So you look at it, this is a sketch, and this also is bringing us very close to what I will say in a few minutes about this. Because it's a computational and a handmade combination here, and that is quite interesting. So let's look, first of all, thank you for your contribution. I think this is really great. You made very sensible contributions, and you were able to describe it, so compliments for that. It's really good. Today we want to talk a bit more in the remaining minutes about data, information, knowledge, just to reaffirm that. Remember, data is unprocessed facts and figures without any added interpretation or analysis. Information is data that has been interpreted, so it has meaning for the user, for you. And knowledge is a combination of information, experience, and insight that may be of benefit for others. Typical example for data that you see here, just independent pieces of words and numbers and so on. And our idea is, of course, to use in the future information as the raw material, as the building material for information architecture. And if you look at the flow and the position of data and information in space and time, so you have the axis of understanding going to the right, and you have the axis of connectedness going to the top, and then from the bottom left, from the point zero, so to say, you have data, then merging into information when you understand the relations between these data. Then you have knowledge if you understand the patterns in which information is arranged. And then finally you come to architecture, to wisdom, if you really understand the principles that are behind these conglomerates of knowledge, of information, and of data. And what we want to look into a bit more specifically is information components, because you can package data into information and then package this information again into components. A last representation of information as a raw material and where it is placed in this chain between data, information, knowledge, architecture, finally going into culture. Always remember this chain, and also revisit your own works that you did now in the first exercise with regard to this chain of increasing complexity. Now let's look at a few examples. I tried to make some very simple examples. I don't know if it's understandable. I will try anyway. And the information components, you can look at them in two ways. You can make the invisible visible, and you can do that by yourself. You don't need computers for that. You just need to reason and look behind and use your knowledge in order to see things that you normally don't see, or people that do not study architecture don't see. You can make whole stories out of what you see. And then the second one is information components on building scale and city scale. So on building scale, I will show you a few examples from cool climates and then from the tropics. Cool climates, this is your climate. This is actually downstairs in your building. Is that phone ringing in Zurich or here in Singapore? This is really funny. I don't know. Anyway, these two gentlemen you might know or you have seen. This is the kitchen in Science City and the building in the Wok restaurant downstairs. I just put it up to show differences and just focus on kitchen as a place where data, information come together and where in the end energy is consumed per person as an expression for the entire building. So here we have an enclosed kitchen, we have artificial lighting, we have artificial taking away of all the fumes that are coming out from the wok that they are making, and there's a huge apparatus behind this just to get these few things cooked there. So in this one, if you calculated the entire ETH campus, it is a high-tech campus in a typical high-tech new university building campus, you use in the excess of 350 to 400 to 500 kilowatt hours per month per person here. You go to a typical kitchen or what you can buy in all these different places in the warehouses, and there you come to maybe using 200 or 250 kilowatt hours per month per person in a house that's run by this kitchen. And here in our cold climates, again, everything has to be enclosed, it has to be artificially lit, you have to control the climate. It has the advantage, though, that you can calculate the flow of energy from the inside to the outside, as you do in all these lectures that you get, for example, in Haustechnik. You look at another example here in Southeast Asia. You look to Indonesia, for example. You see a typical kitchen in one of the typical indigenous houses, and you can see many things. You can only see those things if you understand architecture, or you could also measure it. One of the things, for example, you see the burning material, the heating material, which is at the top, which are just these pieces of wood. And you see these different plates. You see metal plates, you see woven plates at the top right, here out of a natural fabric. And you can see that it's all black. If you have heard today's news this morning, you probably have heard that more than 2 million people have died last year from exactly these conditions of open cooking fires within semi-enclosed buildings, both on the sides of the women who are cooking and on the sides of the children who are sitting in these places. So this is things you don't see, but which you can combine with information that you get from the newspapers or from reports. Here you can see even more. It's not totally indigenous, because you can see on the left side they're already using stone, concrete made stone, still combined with the old way of making a fire, open fire in this house. And if you continue further, you see that there's no real difference from the inside to the outside. It's, yes, there's a membrane in between, but it's by no means the triple glazing that you have behind yourself right now. All the same from the kitchen. And here probably the kilowatt hours used per month per person are in the area of maybe 10 at the most, as compared to the 10 or 20 or 30 or 50-fold what we use for the same buildings. Not the same buildings, but the same functions. Or you look at another kitchen, a more modern kitchen, again you see there is inside-outside relation. There is no doors, so it's completely open. You don't need heating, no air conditioning, but you do need a refrigerator. You need still some water. You have different sources of water. You need some cooking, and now it's gas, it's natural gas and not fire anymore. All these things you see, all these you can package into information and calculate backwards from this information the sustainability ratio of these buildings. Or if you look into the construction, a totally natural construction of natural materials, you think maybe this is a window upstairs. Of course it's not. It's just air coming through, and you can see from that it's really a sustainable material in a sustainable way assembled. Even earthquakes cannot harm these type of structures very much. So this is a very simple view at this. Let's have a more view at the information components applied to a physical building to the outside. Now I don't know if you can hear that from there. This building, you know, it's very close to you. It's the one in the piazza. But the students, what they did is this one here, which is quite amazing in the programming course, answering some of the programming questions. Where you can see the information is produced by the people walking in front of it back and forth. And when you have seen that before, I never get tired of watching this, because it's really a good example of showing how people make the difference and how people emission of heat, in this case, is producing a sensation in terms of light. And that you can learn how to program that and redisplay it on the wall. So this is on the building scale. If we look at the larger scale in terms of cities and integrating urban form with socioeconomic data, you come into a completely different area, and this is actually what we're doing here in Singapore in the Future Cities laboratory. And then you can go into visualizing the structure of urban form, and you can create data sets for fine-scale urban analysis and have all kinds of very strong interlinkages between information packages and future architecture. Okay, I think I cannot go very much further here because we are out of time, but just a few visual examples that we will revisit later in the course. This one here I think is fantastic. Do you know what that is? Can you imagine what that is? Any idea? Any shape you recognize?
The brain?
A brain.
Underneath the red thing?
A brain would be quite, that would be quite something. The author would be quite happy. The author of this was speaking to you last week. That was Stefan Müller, Arizona, and Afian Anwar in Zhengwei. They made this Metrobus project, but really this is information generated by the city, information packages generated by the cities, by the citizens of the city, visualized in a certain way. This is Zurich actually. So if you look at this part, you see the lake of Zurich, and this is kind of the heart of Zurich, where all the information is bundled and coming together, and from there then you record all the trips of people that they make during the day within 24 hours from place A to B in Zurich, and you put them on top of each other like 1 by 1 hour slices, and you get into this three-dimensional information structure. You can navigate that in 3D interactively, and you will be able to do that very soon. And then you can understand this information much better and very quickly. So this is one wonderful example. Hello? Yeah?
Do you know how they gathered the data?
I cannot understand it. How you gather the data?
Yeah.
Great question. In Zurich, it is a simulation of the data. So it's simulated with a program that's called MatSim, produced by Kai Axhausen, also one of the researchers here, and Kai Nagel in Berlin. It's MatSim. We will revisit this program during the course. So this is a simulation which is derived from not measured data, but from simulated data. But it's been verified in Zurich in different places, and you have a very good match between simulation and reality. Here in Singapore, we can show this data, the same image, but from real data that have been measured by people. And also we will revisit that. So this one is simulated data, and here in Singapore we have measured data. And this one here is actually measured data. This is a different view at the city. In this case it's Amsterdam. At the New Year's Eve. If you look just at the floor plan of the city, it will look totally different. But here, in this case, you see where the people were still at New Year's Eve, and you could see that by measuring the activities of people in that city, either by cell phone activity or crossing the streets or wherever they had cameras. So it was, of course, made not on a person-by-person basis that you cannot follow these persons, but just on accumulated data. You can see where the activities are. So I don't want to go this too fast. Unfortunately, you have to revisit this. Just come to the quick conclusions. In this relation between data and architecture and information, the summary would be: information components today of future architecture are important for mainly two reasons. The first reason is to better understand existing architecture by making the invisible visible and comparable. So you do that by showing flows of traffic, flows of energy, flows of light, these things that we discussed in the very first hour, and revisit your own examples again based on that first, to better understand existing architecture. And the second one is to better inform the design of new architecture by simulating scenarios based on the understanding derived from existing architecture. And this simulation and the relation between simulation, theory and experiment for new architecture, this will be the topic for the next lecture in 2 weeks. So thank you very much and have a wonderful afternoon. I'll be around if you have questions, but I don't want to keep you too long so that you can go to your next enterprises. Thank you from Singapore. See you next week. Bye-bye.